Hello everyone, welcome to the channel. Today we are diving into two fundamental concepts in deep learning: overfitting and underfitting. Understanding these can significantly enhance your model's performance. Let's get started. In the realm of deep learning, our primary goal is to develop models that generalize well to new unseen data. However, two common pitfalls can hinder this: overfitting and underfitting. Overfitting occurs when a model learns the training data too well, including its noise and outliers. This results in excellent performance on training data but poor generalization to new data. Imagine a student who memorizes practice questions without understanding the underlying concepts. They might excel in practice tests but struggle with new questions. Overfitting model learns training data too well. An underfitting model is too simple. It cannot capture underlying data patterns. This indicates high bias and low variance. Several factors can lead to overfitting. Complex models with too many parameters, insufficient training data, excessive training epochs, lack of regularization techniques. And consequences can be poor generalization results, unreliable predictions occur in real world scenarios. This wastes computational resources. Techniques to combat overfitting. Regularization adds absolute the value of weights as penalty. It encourages sparsity for feature selection. This reduces non-zero weights by 30%. Regularization adds squared value of weights as penalty. It prevents individual weights from becoming too large. This improves test by accuracy. Elastic net, a combination of L1 and L2 regularization. It balances feature selection and weight reduction. Second and third techniques are dropout and batch normalization respectively. Dropout is randomly deactivating neurons during training. This prevents co-adaptation among neurons. A zero point 0.5 dropout rate improves accuracy by 2 to 3%. And about batch normalization, normalizes input of each layer. It stabilizes learning and allows higher learning rates. It speeds up training convergence by 2 times. So the next technique is early stopping. Monitor validation loss. Track the model's performance on a validation set. Stop training, halt the training process when validation loss increases. As you can see in the graph, number of epochs can lower the graph, but once number of epochs increases, the graph may start increasing. We have to stop there. That is known as early stopping. Benefits of these are prevent learning noise and reduces overfitting. It also significantly saves training time. So here are solutions for underfitting. But before that, I would like to tell you what underfitting is. Underfitting happens when a model is too simple to capture the underlying structure of the data, resulting in poor performance on both training and test sets. Let's take an example. Think of a student who doesn't study enough. They lack the knowledge to answer questions, both familiar and new. Causes for underfitting can be models that are too simple or insufficient training time or inadequate features. So here are 4 solutions for underfitting. First one is increase model complexity. Add more layers, neurons or parameters. Increase network depth from 3 to 5 layers. Feature engineering. Create new, more informative features, combine multiple features into one complex feature. Reduce regularization. Decrease regularization strength. Lower L1 L2 penalty from 0.01 to 0.001. Last one. Training for more epochs. Allow the model to learn more from data. Increase training epochs from 100 to 500. But also remember the early stopping I have told you before. So we are at the conclusion of our slide. First one is key challenges. Overfitting and underfitting are critical challenges. These need to be handled carefully to get better predictions. Second, overfitting solutions. We have seen four methods that are regularization, dropout, batch normalization, and early stopping. Third, we have seen underfitting solutions. We have seen four types: model complexity, feature engineering, reduced regularization, and more epochs. Last one, optimal performance. Balancing these techniques leads to optimal model performance. Thanks for watching. If you found this video helpful, do like it. Thank you.